I guess for this community meeting, we're going to be mostly recording, and then people can view it on YouTube later. So there's two items on the agenda for this week. So the context is that we just had a, let me turn on my camera. We just had an in-person meeting in Taipei, and there's, I think, 250 people signed up. I would say 150 to 200 people showed up in person, and we had a really good discussion on MCP and WASM. So why do we need that, and how did we do it, right? So the two presentations in this community meeting would be Haidai and myself, and we're going to talk about some of um, the things we discussed at the community meeting. So I asked Haidai to go first. So his presentation is use WasmEdge to build an MCP proxy server. So Haidai, please.
Sure. So let me share my screen. Okay, can you see my screen now?
Yes, I can.
Okay, so let's get started. So today I'm going to introduce how to build a remote MCP server, and you can use Rust to and then compile it into WebAssembly, and then use our WasmEdge runtime to execute it as a local MCP server or as a remote MCP server just to connect it. So before we get started, I need to talk about what is MCP. The full name of the MCP is the Model Context Protocol. And the most important thing is not the model, it's not the context, it's the protocol. So basically, it's define a way for the client and the server to switch data and let the LLM know how to interact with these NCP servers to get some local resources or read-only resources or some cloud services to finish their job. So if we see this picture, we can see the couple of different roles, including the host, the NCP client, and they switch data, use the NCP protocol, and with this different server, and each server will act as spatial agent. For example, you can use this server to manage a local SQLite database, or you can use this server to create a local file system, and to create a file, delete a file, or build a lot of different folders. And of course, you can use this server to run some web API. So you can ask this MCP server to fetch some the pull request or the issues from GitHub. So this is the basic idea, and we will have different kind of roles. The first is the MCP host, and basically is the application we are really interact with. For example, if you use VS Code, you use client and use cloud database, or you use the Cursor, Windsurf, and other IDEs. Even you build your own AI agent, you will just list all of the software applications. They are called the NCP host. And you will have the NCP clients. These clients will maintain an one-to-one connections between the client and server. So you will have a host. You may have multiple different clients to interact with different kind of servers. Yeah. So the next role is the NCP servers. It's basically a proxy or it's a very lightweight program. The basic idea is this server only know how to handle this JSON RPC format object to convert the missions into how to use its resource, its prompt, or its other API to interact with the real services. So there are different kind of sources. The one is the local data sources. So basically, you can have your computer file, you can interact with your file system. Even if you have different kind of the application is installed it on your computer, for example, Unity or browser, you can use all of these resources and as your data source and interact with it. Of course, if you have other remote services, you can also you can build an NCP server to interact with, for example, the Google Suite for the Notion API, or you want to fetch the where about tomorrow in Taipei, or you want to get some callbacks from GitHub. So this uh, basically you can do anything you want. Okay, so how to create an NCP server. So you have three different kind of capabilities you have to provide in your NCP server. The one is the resources. Basically, is lots of different data, and each data is just a file like string or raw characters, just some resources stored in the NCP server. And the most important thing is you provide lots of different tools. These tools is callable functions. So basically, if you want to create a file, you may define a callable functions. You define a tool called create new file. Okay, and because if you really want your LLM to use your own resources or tools very efficiently, maybe you have to define some template as a prompt that let these models know how to use your tools more efficiently. So they will provide lots of different prompts for you and for the LLM to know how to use them. Okay, so basically, if you build a full functionality of the NCP server, you have to provide these three different capabilities. And there is couple way to interact with the NCP client between NCP client and the server. So the very easy one is use standard input and output. So if you already use some NCP services, you will find we will use the npx or the UVX, and we follow a package and some argument. Then you can just set up the NCP server and use the standard input output to interact with it. Of course, if you let's take another example. If you have a very powerful machine and you want to run a NCP server, which use this powerful machine to, for example, to build 3D models, to build to generate lots of different pictures. So you will need a very powerful GPU machine. Then you will um, it will not a good solution if you only deploy it in your local site, use standard input output, because you may have lots of different users or lots of different clients want to connect to this powerful machine and interact with it. So before uh, March 26, actually there is a way to use the server-side event. So you can create a server, provide the server-side event functionality, and then you can use your host, your client to interact with them, just follow the SSC way. But after this date, the NCP spec is updated. You don't have to support server-side event only. You can use, a regular stringable HTTP. For example, you can use post or get, the normal HTTP action to interact with this NCP server. And you can also provide the server-side event if you want to, uh, keep the uh, backward support, backward compatibility. Yeah, so there will be three different ways to communicate between the clients and server. And today, because this HTTP is a very new spec, some of the SDK is not up to date. So we have to use the standard input output and the server-side event as today's example. Yeah, but if you you want to wait for a week or 2 weeks, and you will see more different examples that use this new way, the new streamable HTTP way to to communicate with each other. So if you use the standard input output, you can use the following different way to interact with that. For example, you can use npx with any package you want and put your arguments in it, or UVX. Of course, because uh, the Watson runtime can also provide the same compatibility with the standard input and output. So you can use any SDK to create your application, create your NCP server, and then compile it into WebAssembly and then execute it. And of course, you can wrap all of these, for example, this npx or UBX command inside of the Docker instance. Okay. Why we have to talk, the WasmEdge or the Wasm runtime or the container here? The reason is that if trying to deploy any MCP server on your local host, well, there is a thing is that it's not very secure. For example, we just heard and very sad news is somebody download NCP server from the network and then just deploy it, and this guy just leak all of his private key because he just download a problematic package and deploy it. So that's the reason why we would like to, or we prefer to run a local or run these NCP servers inside a sandbox. I believe is very important to avoid any security issue. So here is seen you can use standard input outputs. You already can deploy any Watson or any services, use Docker or use other container tools to deploy your NCP servers in in a better secure way. Okay, so why this is very dangerous? The reason is that how the client to to handle the standard input output basically is just let this client fork or create a sub process, and then it just run this command to deploy a native application on your computer, and then use the standard input, standard output to interact with each other. So if this, SB server is a problematic one, then anything can happen, and you just lose all of your data or something like that. So you have to to choose a secure way to do that. So this is for a NCP server you want to build and deploy at the localhost side. And if you want to create a remote server, then let's talk about the server-side event version. And of course, we will have the HTTP server, and that's why we want to build in our next project called the OpenNCP, but it's not ready because the spec is just updated. So we need to follow the new spec and to create the project. So back to this side, we will create just a very standalone server-side event server. So if you create with the TypeScript or JavaScript, you just need to npm start your project, and you will create a server, and you will allow you to use your client to connect to this server. Not only on the local host, you can deploy the same server on your AWS, your other server, remote server, and then if you have the domain name, you can just connect to that domain name to use it. So basically, you can find that all of this command is basically to execute a native binary or execute a project on a remote server. And the only thing you do is you have to, on your desktop, you need to, npx and then code the NCP remote with this server URL. Then you can connect with it. Okay, and this project is on here, so you can check this if you want to see the detailed code of the NCP remote project. And here is the uh, life cycle between the client and server. Use the server-side event, but I don't think you have to take some time on it because this one will be replaced or use the streamable HTTP way, so it's fine. Yeah, yeah. The new one will be shipped. I believe most of the example will be updated. Okay, then let's get back to demo. So here is my VS Code project. So let me show you what is our my NCP settings. So basically, if you want to execute a NCP server which is already compiled into the WebAssembly, the only thing you need to do is here you can put WasmEdge or any Wasm runtime you prefer. You can just put a command here. And the reason I have to map, for example, make my current folder to sorry, to map in my this demo folder into the guest folder, guest current folder. The reason is that we this NCP server will generate some logs, so I have to create a location to save all of these server logs. So it's pretty easy. You just command and choose the directory you want to put, and then run this one. So basically, because you can control which folder you want to put your log, so there is no way that the Watson, this NCP server can access other files because the file access is limited to this place. So you don't need to worry about uh, it will write some dangerous things on other folders. Yeah, so this is one way if you deploy it in use the standard IO. Okay, and don't be confused if this says the standard IO, because that if you use the NCP remote, actually you don't have to execute the real NCP server on your local host. Yeah, but just for demo purpose, I didn't deploy any remote server. But uh, basically, you can just replace this URL with your own domain name or your own services URL, and yeah, it just works. So just put npx and the NCP remote and your services here. So I can ask some question to interact with it. Say, can you show me the tools provided by, for example, this is native demo. Let me check. So, okay. So it just show that, oh, I query this, this MCP remote to this URL, and there have six different function here, and maybe I can say, can you summarize 100 and 200? Let's see if you can, here you go. You just check, oh, I found this, this tool on the, native demo server, and I want to call this function, and I approve the response here. You use this tool to, to summarize, sorry, to add 100 and 200, and then give me a result. So here is the best demo that you can use, Rust, and you can compile it into WebAssembly, and it just executes it. Yeah. If you have any interesting to see, and it's very easy. For example, this one is the standard IO example. All you need to do is you have to check out the Rust NCP SDK, and you will provide these basic functions. So the only idea is here, you create your services. For example, this is a counter services, and you need to specify if you want to use the standard input output, or you want to use the server side event server here. Just put the transport way inside this one, and then this service is just deployed. Yeah. And if you want to dig into, for example, this is counter, so let's go to the counter.is. Then basically, you just define all your tools, all your prompts, all your resources inside this file. For example, if you want to create a tool, you need to use a toolbox to bound these following implementation and say, oh, hey, this one is my new tools. And these tools provide such different kind of functions. For example, this function will, increase the counter by 1. And this function is to decrease the counter by 1. And you can get value, or you can, a very easy function to say hello to the client. Yeah. And where is the add function? Here. So this one is the function that I demoed before. Is you will calculate the sum of two numbers and just write down your logic here and then compile all of this stuff into WebAssembly and deploy it. You already have a secure sandbox to execute your MCP server. Okay, so that's all of my demo, and if you want to try it, here is the link. You can go to my my NCP Rust SDK to get this example. And if you want to use for example, use your IDE or use the VS Code to deploy this server, you just follow this way. For example, you just put WasmEdge here and your local folder here and the path to WebAssembly, and you can execute it. Of course, this one is the server-side example. You can just try it. And the only thing you need to check is the Rust SDK is in very early stage development, so you will find some breaking changes between the recent commits. So if you want to try it, you have to ensure that you maybe you have to keep your current version, or you have to up to date always to ensure that you are using the current API to create your services, because this is very in very early stage and is in very active development. So here is all of my demo.
So had I talked about some of the challenges of running the MCP service, right? That's so I think, we had a very successful meeting talking about MCPs, and there's a I think in the community people have an argument to say whether MCP matters or not, right? That's but this is a a tweet from Google CEO. It was not April Fool's. It was the day before that, so he's not joking. So to MCP or not to MCP, that's the question, right? And I think a lot of us answered. So that's MCP is the way to go. But before we do that, I'll take a step back because one of the very interesting and very relevant products that recently got released was from Docker, and Docker was one of the sponsors of that event. So I want to spend a couple minutes to talk about this Docker product, and I also think that's really relevant to the issues that Haidai talked about, right? So namely, that's in most cases, the current setup of the MCP server is not secure. It could, steal your private key or overwrite your file system or do a lot of bad things in your system. So, so it is important to figure out a way to run MCP servers in a container, right? Either in Docker or in WasmEdge, right? In whatever the way, that's your favorite container environment. But I want to make a case for WASM. So let's take a step back and see what Docker has released today, or maybe yesterday, but it's definitely this week, right? So in the world of running local AI, there has always, people were joking about the impossible triangle. So this, figure is the impossible triangle is also called the Penrose triangle. I think it's Roger Penrose drew this first, right? So it's an optical illusion, but it says something that is three things can't be all true. You can't have all three things together, namely Docker, Mac, and LLM. Meaning that's is it possible to run Docker? You can have Docker and LLM, but you can't run on the Mac GPU. Okay, you can only run on very slowly on the Mac CPU. You can have Docker on the Mac, but in Docker on the Mac, it's difficult to run the LLM because there's no GPU access. So there has always been the challenge of using using containerized environment to run large language model, to run AI model in general, right? So what Docker has released yesterday was very interesting. It's called Docker Model Runner. If you so basically you just upgrade your Docker desktop. A lot of us, I think most of us have Docker users, and we have Docker desktop. Just upgrade it to the latest version, and you go to the features in development, and then you can check the enable Docker model runner, and that's it. You could give it port number so that it can expose the API, right? So once you do that, you are done. That's your Docker now become Olama. Your Docker now becomes now magically gain the capability to run large language model, just to run large language model in um, on GPUs, especially on the Mac, right? So the way to do it is actually very simple. If you have used Docker at all, or if you have used Olama in the past, it is something very simple. So first you use Docker model pool, and you gave it an image name. It would pull the image from the so in this case Llama 3.21b, and it's quantized as 8-bit, right? So you pull this model, you download this model onto your local machine, and you say Docker model run this. Okay, so Docker run instead of Docker run, you say Docker model run this image, this model image. It will run this model, and now you have a CLI interface where you can have a conversation with it. Once you had the conversation, you can say bye. You can leave the CLI. So basically, you have a chat interface right there on your terminal, and you can also access it through API. So here you see, if you go back, I gave it a port number 12434, right? So you can access the port number localhost 12434 and use V1 chat completion. So that's the OpenAI, URL format, right? And give it the OpenAI JSON message. That's basically tells it, which model to use and what messages to use. That's you would get a response by querying this API with Docker running on your local machine. So that's if you look at that, that's very similar to say how Olama works, right? That's except you don't have to download Olama. You don't need to install anything because you already have Docker on your machine. So with that, you are able to run all the popular models that's being released, right? So this reminds me, that's why we use WasmEdge or LlamaEdge, because as it easy the Docker tooling or Olama tooling or even PyTorch or ARM Studio, they're very easy to use, they're very easy to experiment with, but they have some drawbacks if you want to deploy it in production, right? So in order to go deploy in production, we see again and again people develop those applications using other tools, but using LlamaEdge to go to production. And to showcase this, the reason why, I want to show you the image size for, say, PyTorch, right? And Python itself. Say Python itself, if you use, if you're not using, say, large language model at all, you are just using Python to run, say, a MCP server like Haidai just described in a container. You are looking at the container size. The container size itself is 360 megabytes. Okay, and if you add PyTorch, if you want the container environment to be able to run large language model as well, you are looking at gigabytes of image size, meaning the disk size and the memory size, right? If you look at the Olama Docker image, meaning that's Olama with all its dependency installed, it is over 1 gigabytes as well. So it's so those are all pretty heavyweight tools that you can while you can use them, they are it's very convenient on your desktop. But if you want to deploy it if you want to deploy your application in a highly efficient manner, it is really hard. So if you compare that with WasmEdge, the WasmEdge runtime, that's including not only just the image, by the way, the virtual machine image, but also all the dependencies that require to run the virtual machine, meaning that Docker desktop plus that image. Okay, that's comes in depending on the system that you have. Say the Android system is coming in under 1 MB. In most systems, including all the dependencies, we are looking at 20 MB to 60 MB, right? Depending on the underlying or whether the system has underlying libraries, right? So to have everything included, you are looking at 60 MB, and compared with a regular Docker image for Python, which is 360 MB, and if you want to do any of the AI stuff, you need 1 GB to 8 GB, right? So that's pretty much summarize why we want to deploy with Wasm. Although you can develop with those developer tools that you already installed and you find easy to use, right? But when it comes to deployment time, you want to start a OpenAI compatible API server that can work with your other agent and tools and your MCP servers. That you would really want to use LlamaEdge to go to deployment because it's just so much smaller and so much more efficient, right? So there are a couple more points, that's compared with, tools out, most of the desktop tools that let you chat with a large language model. LlamaEdge are model agnostic, meaning that's not only support large language models, it support embedding models, visual models, Whisper, which is speech to text, Piper, text to speech, Stable Diffusion, and Flux are um, um, text to image. And the GPT Solvits is also text to speech, right? Supports a large variety of models without you having to change in the code, right? So if you write, an application that does inference, you can swap out the models underneath it, and the code would stay the same. And it's runtime agnostic, so it's the same code compiled to Wasm, and it's the same binary application that runs on CUDA, WebGPU, Metal, MX. That's different hardware underneath it. Different software runtime. And because the software runtime is agnostic, it's also hardware agnostic. So it runs on GPU, CPU, or anything, right? And it's very focused on deployment, as I just mentioned. That's it is lightweight, so it's around 50 MB. A lot of times, a lot smaller. We can see it can go all the way down to 1 MB in total dependencies, right? So it has minimum dependencies. You just install those binary files into a system, and then run the binary WASM files, right? It doesn't require root access. It doesn't require a daemon, anything like that. It has a single portable binary file that you can use anywhere. It supports a wide range of hardware so that you can deploy it, as needed, right? So in a data center environment, that allows us to buy, say, GPU on the spot market because we don't really care which GPU we got, as long as that's as soon as we get a machine at low price, we just slap WasmEdge on it, and all the AI application that we have just run without recompiling, without anything. We just copy the binary files over, and it's gonna work, right? So that's makes it a really good deployment option, not only for large language model, but I would argue also for MCP servers, because as I mentioned, there has been multiple incidences of MCP servers not being secured. So we really need, instead of running them as a user process on your home computer, you should really run it as in a sandbox environment. So instead of downloading 260 MB of Python stuff to run it, why don't you just download the 20 MB of WasmEdge and run it, right? So that'd be the argument to run sandbox MCP servers in the Wasm, especially WasmEdge environment, right? So, next I want to cover some of the use cases, some of the demos that I did during the talk, right? So one is, so how are we going to use MCP in some of the common use cases or some of the common agent applications that we have developed so far, right? So one of them is we have a PR review agent, meaning that's so actually let me see if I can show you this demo. So you guys can see it, right? That's you know, see the screen. Okay, so this is a very simple UI, so it has an agent behind it. It allows you to choose from different models. So here I chose a a GaiaNet model that runs a chain encoder 32B, and it's running on Llama Edge. And well, for that, I don't need an API key, but I give it any GitHub URL. So let's say I want to review this. Sorry. Ah, mm, sorry. Where's my, okay. This, perhaps this is the easiest way to do this. So pull requests. I think we want 24. So this is a pull request in. Okay, so we want to review this PR. And if we go back, we can see, where is it? Okay, here. We can see there's a bunch of files that changed here. So a bunch of commits, right? So I think one of the community members from made those changes. Those are mostly configuration changes. And if we come back here and we say, give it a little context, we use the WasmEdge runtime to run the compiled Wasm application. And we can also use the lms.txt files in the repo. So it typically gives you the background of what this repo is about, what is the file structure, and things like that, to give the large language model a little bit of context. So what this does is that this gonna take, go to the repo and takes the pull request, get all the files that has been changed, the previous version and the current version and the change set, and then feed each of the files with a set of review prompts, into the large language model to get the review results. Once you get the review result, it will be able to have the option to allow you to post it back to GitHub, right? So while we are waiting for this to come back, we can, you know, um, continue our presentation, because this is one of the cases that's currently being developed as agent, but you can really use MCP to abstract away a lot of those concepts and then make it shareable to other people. So for instance, if I ask the large language model action around GitHub, the large language model would know that it needs to somehow access GitHub. Sometimes it would be require API key, or require a personal key to access a private repo, right? So that would be something that is ideal for MCP server, right? So you can use the MCP server to encapsulate this action, so that when the large language model is asked to do something about GitHub, it knows to call this function to this server to get the files and other information that's relevant to this review, right? And once it's done this review, it can also ask the MCP server to post the review back into GitHub on your behalf, right? So that would be one of the ideas. That's to turn one of the applications that we have built so far. Let me go back. Is it? Where is it? Oh, okay. So it's done. Okay. So you can see there's the cargo, there's evaluation, this some files are not changed. It's talk because those are configuration file changes. So it talks about it's very verbose, because I gave it a very long. I asked it to describe in details, what's changed in the in the PR, right? So what did in the Docker file, and it gives you suggestions that you should do this in the Docker file instead of not with the trailing, slash, and the Docker compose file, and such, right? So now you can post back, if we have a GitHub MCP server set up, the large language model will know that it needs to post this back to GitHub, and the MCP server would provide a function to do exactly that, right? So this is one of the use cases for uh, you know for to turn an existing agent into an MCP, right? So there's another one that's I find really interesting. Is one of our LFX mentorship students who's working on a project called Rust Coder, and you can see the GitHub link here. It's being tracked in the issue under the WasmEdge repository, right? So what it does is that so I don't really have time to do a full demo here, but it's a it's a set of Docker images. So once you start those, it would use a large language model to process a user request. To say I'm vibe coding, I ask it to generate, say, a web service that transforms uh, some JSON requests into database records, right? So very typical thing that you do in most applications. So it would generate all the files that needed for the application. And then it would spin up a Docker container to run all the to run the Rust compiler, so that it either succeed, or when it failed, it collects all the error messages and send it back to the LLM, ask it to modify the text, right, in the generated code. So it goes on, repeats until the compilation passes, and then returns the result back to the user. So this whole process can be encapsulated into MCP, right? So if the large language model detects the intention is to validate or run a particular piece of software project or software or source code that has been generated, it could make a call to this MCP server and pass all those files to the MCP server, and the MCP server itself could call another large language model in the iteration loop to improve this code and until it passes, right? So this is another example where we are currently building a handcrafted agent, meaning all those processes are being hard coded into the agent application. But I think there would be a way to abstract it out as a MCP service, so that and a lot of those MCP services would be WASM based, but the Rust compiler probably wouldn't be, unless we have there's project like turning Linux container into WASM, right? That's compiling Linux container into WASM. That's that. We could do that and then install the Rust compiler on top of that, right? But but short of that, that's there would be a mixture of Docker containers when the cost justifies that, but would be a lot of WASM functions that acting as MCP services around those large language models. So I'm really excited about all this uh, all the things that could happen here, right? That's so before we end, I want to show you some of the tools that we have built, because we have built a whole set of agents, and now turning them into MCPs, right? So we have a website called Low Code Rust. That's it's a set of Rust tools and learning materials. They are all AI enabled, using a large language model that's running on WasmEdge, right? So you can there's a learning assistant that we talked about in the past. You can ask questions, ask it to come up with examples. A code generator is the Rust coder we just talked about, generate complete code and then do the compilations loop until it's self-improved to the point where it can handle its own, right? We have a Python to Rust translator, which has the same idea. That's like give it a Python program, translate to Rust, and then try to run the Rust code. And there's PR reviewer, and we have PR explainer. That's to review or explain GitHub PR to different personnel. So so you can have someone who's a a reviewer, developer, or someone who's a product manager. So there's all kinds of different roles that you can customize this PR reviewer, but they would all use MCP to handle the interaction between the large language model and the GitHub, right? Yeah, so there's another initiative that we talked about in today's meetup. It's called OpenMCP, meaning that's, so we want to provide a set of WASM tools that allow users to build their MCP servers in WASM and to share their MCP servers and also to build their security policies and other things in WASM as well, and to have them shared across the internet, so that I can provide a WASM-based MCP service securely from my computer, and then everybody else would be able to use it, right? That's because I'm running in WASM, so it's a sandbox environment, so it's um, pose much less risk to myself, so I can offer this service. Right? So there's, as you can see, there's a wide range of topics that we discussed. It's MCP is such a new thing, so we tried very hard to explore ways how WASM can play in this ecosystem. And so yeah, that's pretty much it. So